When it says same temperature and pressure, the only options you have here, the only options you have when it says the same, first of all, it does not mean standard. You can't use standard temperature and pressure. And for those of you who did no homework over the break, the test is tomorrow. It is all for response with the exception of 20 points. It will be your last test grade, okay? We have lost 7 instructional days. We are not getting those back. The exams are being moved by a grand total of 1 day, okay? You will see stuff on that exam I will not teach. I will not be able to get to. I cannot get those days back, okay? You're sort of SOL. I can post videos. You can either choose to watch them or not watch them, but I cannot recover 7 instructional days, okay? It's just not humanly possible to do that, okay? Your benchmark is technically right now. You're taking a gas law test tomorrow. It is going to serve as your benchmark.
Oh, that works for me.
Okay? Now, but see what's up here? A test review is you asking questions. If you didn't do any homework and you don't have any questions, you have no review. We're moving on to new stuff. Okay? I'm not spending time in class practicing what I asked you to do last week. Okay? So if you didn't do any, you've got no review. The test is tomorrow. Okay? I sent out stuff on Remind. That's a grand total of, I think, 8 people who got it. All right? I posted stuff on the website. If you never checked the website, you never saw any of it. I'm sincerely sorry. Okay? I reminded you and asked you to do that before the snow the Friday we got out of school. That's all part of being responsible and in class. Now, when you look at this on the test tomorrow, how many compounds are in the question? I mean, you see, I see hydrogen, I see nitrogen, and I see ammonia. That alone should tell you to write a balanced equation. Okay? What does it say is produced? So you know what goes on the side of the arrow. Okay, what's the formula for ammonia? NH3. All right, what did it say ammonia was produced from? All right, hydrogen and nitrogen. So hydrogen plus nitrogen. Do we know anything about them? So put 2's on. All right, from there, we're going to need to balance. So we know hydrogen has a 2, so we need a 2 there. That's how many H's? So we're going to put a 3 there. Any questions about that? Now, this is the part we were talking about with same. The question says you have the same temperature and pressure. Doesn't say standard. You cannot plug in a temperature and pressure if it says same. Okay? So, we cannot use PV equals nRT. We cannot use a P1, V1, or a V2 over T2. Anything that's got a temperature or pressure in it. Because you don't know it. Okay? So that leaves us with a T-chart. That's all we've got. All right? So they gave us a number. They gave us 17.5 milliliters of ammonia. So 17.5 milliliters of ammonia.
You don't have to change it here, right?
Nope. You can leave it milliliters. If you wanted to change it to liters, you could, but it's not required. All right, so we're going to put milliliters of ammonia on the bottom. And we're going to change it to whatever we need on the top. So what did that ask us to find? So we're going to change it to volume of hydrogen. So milliliters of hydrogen. From there, where do we learn we get our numbers from in a volume-volume ratio? The equation. So when we look at the equation, what's in front of hydrogen? A 3, and ammonia a 2. So multiply and divide, and you have your answer. Anybody got it?
26.
26 point what? Milliliters of hydrogen. Questions? All right, for number 2. Number 2 is a mass and volume question. Again, when you look at it, how many compounds do you have in the question? I see rubidium chlorate. I see oxygen. That says 2. And I see the word produce. And I see the word decompose. That tells me I'm going to need a what? I'm going to need an equation. There are 3 of these on the test tomorrow out of the 11 math problems. So, how do I write rubidium chlorate? Now, first of all, do you get your oxidation sheet tomorrow on the test?
So are you gonna write the polyatomic thing out?
No.
Then how are you supposed to do that?
What are you holding in your hand? Okay. What are you supposed to be holding in your hand?
How do you get chlorate from the periodic table?
You don't? What do you think I want Caroline to pull out? There you go. Turn to page, best guess, 6 or 7. Did you find the list of polyatomic ions? Uh-huh. Is chlorate on there? Yep. Okay. Now, I know you're not used to using them because I've given you all these extra ions. But for the remainder of the semester, I'm going to be trimmed down to what the state has given you. I will not exceed the polyatomic ions that are on that reference table. Okay? I will keep my ions to just that short list. So, where are you going to find rubidium's oxidation number at? Periodic table. What group is it in?
1.
It's in group 1. All right. Chlorate is on the reference table. What is its polyatomic ion? Is what? ClO3. Its oxidation number is a 1 also. All right. So the 1s are going to cancel out. Now, how does it decompose? Where are you going to find that at? The reference table. Do you remember? Some of y'all do. But a lot of you don't. So how are you going to figure it out? It's on the reference table under what? Under decomposition. What's it change into, Sailor? Because you're looking at it. I can tell you're on the right page. Alex is yelling it out over here. All right, RBCL and? All right, tell me what formula you use because I know not everybody's where you are. All right, you're under metallic chlorate, so read the equation to me that you're using. All right, does everybody see where Caroline, Diamond, and Alex are at? Okay, that's the formula they use to get the products. Everybody remember doing that? If I put one of those on the test, do you know how to get it or where to find it on the reference table? Okay, so what do you need to check other than writing that? There's one other thing we need to check in case I don't give you one that cancels out. Oxidation numbers. Did these oxidation numbers cancel out or no?
Yeah.
How do you know?
Because they go down.
Yes. RB had a +1. Chlorine had a -1. Check that because I might not give you one that cancels out tomorrow. So don't assume that I did. Okay. They had to here, but they might not tomorrow. Now do what Chris said and check, see if it balances.
Question.
Yes.
So on the test,
Yes.
is there going to be an equation that you already have written?
Yes. Out of the 3, I wrote 1.
Okay. Great.
I wrote 1 out of the 3.
I don't have to.
You have to balance it?
Pretty sure I didn't balance it.
Do we have to do the oxidation numbers?
No, I wrote the subscripts. I just didn't balance it. All right, so is it balanced? No. So what does it balance? Okay, so we're going to put all right, everybody go with that? All right, so what formula do we use to solve this? Do I have some numbers that will allow me to use a formula here, or do I need to just do a T-chart? We're going to use PV equals RT. What makes this different from that? That's right. It says STP. Okay? Everybody see the difference? That one said same. That one says STP. All right, so we're going to use PV equals RT. right, we all know at this point, temperature is 273, pressure is 1 atm, and R is 0.0821. If you do not know that, you're sunk tomorrow on the test. There's no point in me even fixing that. So, what did they give us in the question? Volume or moles? They gave us moles. They gave us 25.3 grams of what? Oxygen. All right, so 25.3 grams of oxygen. I'm going to change grams to moles. I'm going to put 1. Oxygen has a mass of what? 32. If you had forgotten and left it at 16, you would have messed up your diatomics. You want to bust that? All right, you'll have detention. I'll change it here and fill out the form in a little bit. All right, so 0.791 moles. All right. Questions? Everybody okay with that? I haven't done anything bizarre. We've just been using PV equals nRT, and I plugged in what we know. Pressure's 1, V we don't know, R's 0.791, 0.0821, temperature's 273. Solving for V. I get 17.7 liters. Anybody else get that?
Yeah.
Okay. Now, have I done anything with that balanced equation we wrote? That should tell me that I'm not finished. I have to do something with the balanced equation if I wrote the balanced equation, right? So what piece do I still need to do? The T-chart, the volume ratio. All right? So now I need to change my liters of what? What was this right here?
Oxygen.
So this is liters of oxygen. So I'm changing my liters of oxygen into liters of whatever that asked me for in the question. So what did that ask me for in the question? Liters of what? So now I'm going to rubidium chloride. So RbClO3. So where do the numbers come from to do that? So rubidium chloride had a 2 and oxygen had a 3. So times 2, divide 3, I got 11.8. Questions? Yes.
Okay. One more.
Mm-hmm. Say what now?
Can we have used the other one, like the big and equals?
Uh-huh. Yes. But instead of a 2-step chart, you're probably going to have a 4-step chart somewhere.
I'm great. Never mind.
Yes. I told you that when we did it. You can always use that formula. It's just harder to use that one because the charts are longer.
Wait, so which other one do we
Yeah, no, I'm sorry.
We use PV equals N double something else too. Is it just to find like the volume of an element?
You can. We also did it to find moles. We did it when we were finding temperature. It just depends on what information they gave you.
So if they're asking you to compound,
I would, yes.
and then if they're asking you for like something like moles,
Yes. Yes.
but that would only have one compound, right?
If it only has one compound in it and it just says find the mass of bromine and it's giving you a temperature and pressure, you can choose which formula you want to use, yes. Okay, but if it's giving you a balanced equation, I would use PV equals nRT because it's shorter. Now, if you use Big M and you keep track of your compounds, you can certainly use Big M. I mean, I can show you how to do it with Big M. It's just more steps, which is usually why I don't show it that way in class. Okay? Devontae. Yes, we talked about it before the snow. Does anybody remember what days I said?
No.
Today and Tuesday. So today and tomorrow. I will even do this. I will be here today, tomorrow, and Wednesday to do makeup work of any kind. I will even make test corrections today, tomorrow, Wednesday. Now, since I'm doing that, let me be clear. When we come back from Christmas break, I'm not doing old makeup work, okay? I'm not. I realized that it snowed last week. However, most of the stuff I'm referring to that needs to be made up is not stuff you missed right before the snow. It's old stuff. If you have any missing work of any kind, it must be made up by this Wednesday. Okay? When we come back after the break, and I'll look at my calendar sometime today and let you know Wednesday what days I'm going to do review when we come back. Because I told you I'd give you 3 opportunities to earn a 1.5. When we come back, I'm not doing old tests. I'm not doing test corrections. I have a quiz from November, Miss Wall. No. If you got that hanging out there, that needs to be made up by Wednesday. Okay? Because if it's not made up by Wednesday, it's not getting made up when we come back. When Miss Curry gets on the phone, I don't know why she hasn't made any Sunday announcements lately, but when she gets on the phone and starts talking about making up work after break, that does not apply in my class. Okay? Now, if you have something missing from January that needs to be made up, that is certainly eligible to be made up in January. But November quizzes cannot be made up in January. Okay? Yes.
Okay, so I'll be here.
Yeah.
I obviously have detention tomorrow.
Clearly.
So.
And you have it regularly.
So.
Stop sitting in the driveway.
You know what? I was thinking about life. I was impressed. I didn't want to be here.
I feel you.
Can I
Ask Karina.
Yes.
I'm here till usually about 4:30. Some days I'm here at 4:45. But generally about 4:30. Okay? Monday, Tuesday, Wednesday. Not staying Thursday. Calling it my Friday. Huh? Friday's just Friday. You'll be a speed bump Friday if you're still here about 3:40. I'll give you a 10-minute head start. All right. Now, since we're done with the opening, I gave you 3 worksheets to practice with. All 3 answer keys have been uploaded. Monday of last week has the volume homework. Tuesday has the mass volume homework. And Wednesday has the gas law review sheet. For those of us who actually did any of it, do you have a question? Huh? Oh, well, if you don't remember it, I certainly can't answer it. I have one more to hand to you, which I'm going to give you shortly, and I will upload the key. I forgot to do that this morning. I will upload the key here in a little bit, which is just the multiple choice part. But if you've practiced nothing, there's not a lot I can do for you. I'm going to take your stunned silence as you did nothing. Oh, you have to think, okay? Well, while you're thinking, I'll hand out the multiple choice part. Now, I told you that there are 10 multiple choice questions. And this is the only part I didn't hand out before the snow because I really sort of thought we might be back before today. All right? And I will upload the answers to this to the website. So that you... I don't have them.
Oh, we can come back. Yeah. She would
I know they've talked about this National School Day and another day in the day in January. Have they decided anything else?
No, they won't decide anything else until after the January 14th board meeting.
So will it be spring break, you think? Or will it be Saturday?
They have February day, they have a March day, and then it'll be spring break at the end of the year.
Her daughter's that's fine.
I mean, if you look at the calendar, it tells you what days are the first to be chosen as makeup days. So, it's just what it is. And the bad part is we're still in December. So probably we don't get a lot more bad weather. All right. So do you have any questions before we move on? Huh? No, I won't. It will be your last test also, in case you missed that. Yes. Yep. Let me find 11.3 so I know what it says.
So I was trying to do this paper and my sister drew.
All right. So in number 4 on 11.3, it says magnesium reacts with water. All right. If magnesium reacts with water, that should tell you need a balanced equation because it's got 2 compounds in it. All right. What kind of reaction does magnesium reacts with water? What kind of reaction does magnesium reacts with water? It's a metal oxide in water, you think? All right. I hear single replacement and I hear a metal oxide plus water. One of the two of them is right.
It's not the metal oxide.
It's not the metal oxide. To be the metal oxide, it would have to be MgO plus water, which is why it's not that one. Okay? It is single displacement. So if you look under your single displacement, which one does it fit? Okay, it's not a yes answer. All right, what does B say? All right, an active metal replaces hydrogen and water. So what do I get?
MOH plus H2.
All right, so MOH plus H2. So what's going in the M spot? Mg, OH, and then plus H2. All right, so all we have left to do is check our oxidation numbers. Do I need an oxidation number on MgOH or do they cancel out? What's Mg's? Okay, what's OH? Again, remember, you're only getting your reference tables, no oxidation sheets. And again, I will stick to what's on the reference table. So check OH on the reference table only. -1.
Can we write in those numbers? It's just as negative as possible.
Say what now?
Can we write in the numbers on here? Because it's just as negative as possible. So I'm gonna do this here.
I don't care.
We can,
All right.
We can write that.
Yeah. So 2 comes down and 1 comes down. So when you look at that, is the equation balanced? How many H's are on this side? 4. So I need a 2 here to make 4. 2 O's, 2 O's, 1 Mg, 1 Mg. All right. So what do we know in question number 4, Karina? What did it give us? It was STP. All right. PV equals nRT. So 273, R is 0.0821, and pressure is 1 atm. All right, so we're either looking for volume or moles.
Ms. Wall,
Yes, ma'am.
can you send Devontae Pittman to the office for a moment?
I will.
Thank you.
Welcome. 652 milliliters is what they gave us. All right, can we leave it in milliliters? No, it needs to be liters. So 0.652 liters, and it's hydrogen. Okay, now this is different than the one we worked in the opening because we're starting with the volume. So since we're starting with the volume, we want to go ahead and do what to it? We want to go ahead and change it. So we're going to go ahead and change the liters of hydrogen into liters of whatever they ask for. We're not going to end with the volume ratio. We're going to start with the volume ratio. So what did they ask us for? They want to know how many grams of what? So we're going to go ahead and change it to magnesium.
So I forgot to do that, and I did like
You can do a mole ratio later if you forget, and that's fine. That's why I said on whatever day I taught this, a lot of you would figure out how to do the mole ratio, and it is A-okay. Okay? There's nothing wrong with it. So 1-to-1. So this one is a 1-to-1 ratio, and you get 0.652 liters of magnesium. Okay? Now, from there, it works just like what we did before we left for the holiday when we took the last quiz. All right? PV equals nRT. All right? Volume is 0.652. Moles we don't know. R is 0.0821. Temperature is 273. Divide.
Did they give us in the problem like a number, like this, how many pressures of this element, and we're supposed to find volume and we put that compound element with that.
So what now? Say the question again.
So like if they gave you a number for like volume and they said 6, like I can't remember the number, 652 milliliters of hydrogen, and you had to find moles. Like if it was reversed and you were having to find the volume, would you put the same compound element for the volume?
Mm-hmm.
So whatever element or compound goes in PV within our G, that's what you use for all of them.
Yeah. All right, so I got 0.0. Whoops, my battery's gone. My battery's just died. 0.291 moles. All right, so from there, a lot of people stop there, but where did I just find? I found moles. So what do I need to do from there? Change it to grams. And I have to remember that this was what? Magnesium. So 0.0291 moles, and then do moles to grams. So 1, and then magnesium is 24.3, and multiply. And I do it, but I need new batteries apparently. That or my calculator's just broke. Point 7 is right. I remember that answer.
But we don't have to round there.
Yeah. Anybody else question on something they did while we were on break? That was number 4. Anything else
Yeah.
that you didn't know how to do?
17 on the gas wall.
All right. All right.
While you're getting that settled, have you talked to the director about her play audition?
Oh, yeah.
About what?
The Oklahoma thing, the clutch thing.
She put it on the board, but I didn't look at it. I do know the concerts tomorrow and most of the field trips are canceled.
That helps nothing.
I know. I didn't ask about the play. Or I can go look at the board real quick.
Yeah.
Yeah, can you do that, please?
Yeah.
Thank you. So,
Go ahead.
oh, okay, wait.
Says the 19th.
What is that?
Thursday?
No,
Wednesday.
Wednesday. Says the 19th now.
Thursday too, so.
So I gotta stay every day this week? Oh, no.
Says the 19th. What? Huh? You don't have it?
Yes.
You're not here?
Does it have to be from a Providence or does it need to be
What happened to you?
Yes, thank you. A musical. I think. Just do Broadway.
Here.
I'm doing
All right, number 17. All right, so 17 has a typo in it. That C is supposed to be a large C. KClO3 decomposes into KCl plus O2. And you'd have a 3, a 2, and a 2. All right. All right, so we don't have STP this time, so we got a few more numbers to calculate. All right, so 575 millimeters of mercury. We have 38 Celsius. And what else do we have? 12.8 grams. And the grams is of KClO3. All right, so we got to convert. So 575 divided by 760 is going to give us 0.756 ATMs. Everybody remembers why we have to do that, right?
Yes.
Okay, Okay. All right. Is that 122? Caroline, since that's your question, is that 122? Yes. Okay. All right. So when I get there, I've got liters of KClO3. So all I have left is to change my volume of KClO3 to whatever they ask for. So 3.54 liters of KClO3 into liters of, I imagine that's for oxygen. Liters of oxygen. So we're going to have 3 to 2 times 3 divided 2. 5.3.
Okay, that's what I got. But I was just confused with the second of the potassium chloride is the other time.
Yeah, because I didn't give it to you, so I was being kind and telling you what it is. All right. Anything else on the review sheets that somebody did and had a question about? Huh? No. I'm just going to post the answers. Anybody else? Questions? No? All right. If you will, find your notes. We're going to move on. Now, for those of you who didn't do any work over the break, I'm sincerely sorry that I cannot provide time for you to sit and work in class. Okay? But like I told you a little while ago, we've lost a total of 7 instructional days. We're not getting, we've lost 8, but we're getting the 18th of January back because they made it a regular day. So technically we got it back in this semester. So we've lost, well, we were losing time Friday for the talent show. So I'm not sure. Not sure we're getting all that back. Now, so we're going to move on and talk about solids, liquids, and gases today. Now, test is tomorrow. You're going to have the entire class period. If you're not here to take it tomorrow, for whatever reason, you can either take it Wednesday after school or it'll be in January. I really recommend, even though some of you are sitting here going, I'm going to flunk the test, I guarantee you if you flunk it tomorrow, you're going to flunk it higher than you're going to do if you wait to January. That's the truth. Cold as that sounds, it will be a higher F than it will be if you wait to January.
Dang, first, what about looking at the flunky? What about just gonna get like a D? That's flunking to me.
January will look even worse. Because think about it. Today is December the, 17th? You're going to have to wait to January the 2nd, 3rd, or somewhere in that ballpark to take the test. It will not be pretty. Now, we're going to switch and talk about solids, liquids, gases, and their properties. Okay? Sure. Now, as a review for tomorrow, what does kinetic molecular theory apply to?
Everything.
Okay. It applies to all solids, liquids, and gases. So if I ask you a question about that tomorrow, do not pick the answer that just says gases or just says solids and liquids. Okay? All states of matter have motion, not just liquids and gases. They all do. So when we think back, at least I would hope at some point in your science career, you should have seen some kind of picture that showed you that a gas had particles that were spaced very far apart. You should have seen a picture that showed you that a liquid had particles and they need to be closer together than this, but I'm trying to draw them the same size as the gas particles over there. But the liquid particles should be very close together. All right. Now, for a solid, because again, I need to draw them in approximately the same size, because if I don't, and I draw them much larger, students get a misconception that solid particles are much larger than liquids and gases. I'm going to draw a smaller piece for a solid so that I don't have to draw 8 million of them. Okay? Now, because of this information that you should have seen in other science classes, we should have some basic understandings about the properties and the functions of solids, liquids, and gases. Okay? So, when we talked about the motion that the solids, liquids, and gases have, that's on your test tomorrow, possibly in multiple choice, you should be able to pull that information based on these pictures that you've seen in other science classes. Okay? Is what?
Wait, can you refresh what KMT is?
Kinetic molecular theory. All right. So kinetic molecular theory is the idea that the particles in matter are always moving. Okay.
Morning, McWall.
Morning. How are you?
Charisma.
Oh.
You know some of the kids I expect from the middle school to be in your third period.
Yeah. I'm forever getting people in third period.
It's crazy.
It's
Yes.
like crazy, man. Recycle.
It was better than you than my parents did.
It's all good.
Thank you.
This is not for. Mom run away.
I'm so like, oh.
Somebody sat down.
She had to.
You really hate your fourth period. That's hilarious.
But hey,
Honestly,
first lesson almost over.
yeah.
You know,
You're almost free, and then you get a whole new bunch of stuff.
it can't be as bad. It can't be.
Probably.
Okay, see, look.
Can't be.
They could all fail.
That would be easier for you.
Half of them are going to. When you refuse to take a test or a quiz or do a lab,
Would you have them?
the outcome is certain. Huh?
Would you have them?
Don't know. They keep telling me they're taking it on Apex. So they tell me every day. All right. Everybody caught up? I hope so, because I just turned the page. Now, we're going to draw a chart. Okay? All right. Let me put motion here.
Is this supposed to be like a chart?
Yep, I'm going to draw the lines in a second.
I'm gonna wait till you do all
I
that.
was writing it like as a.
I just said it was going to be a chart.
I mean, none of it would make sense. He's going. He's going.
That's like Robert Graham.
None of it's
State was doing it.
I don't even have. It's easy, it's like solids, don't move a lot, gases move a lot.
Yeah, there's some specific words that we need to add in, but beyond that, yes.
There's no like equation, it's just straight like.
Now, Wednesday is going to be math.
Yes.
Didn't you say we were gonna be done with math?
No, I said there will be pieces of math woven in the rest of the semester.
So.
And I will be honest, between now and exam day, for you, it's going to be a little more disjointed than you would like. And that's because I'm going to pick things that I think have a greater chance of being on the exam. So things that might help it make more sense.
The things we're not gonna learn, like little, like 3 questions on the test.
Yes. So, for example, we were going to do the specific heat lab, which goes with what we're learning Wednesday. We would have done like Thursday or Friday, which would have been your last lab report. I chucked it. So you won't have a last lab report, which will please many of you, but it will also take out your last lab with a bunch of burners because we just can't do it. The specific heat lab.
But
Was it gonna be
that one wasn't that bad.
No, the specific heat lab, A, was not, it was an easy lab, and B, it was an easy lab report. But it was a lab report. But it's been chucked.
My feelings are, we're fine.
That's good, because it got chucked. But the point is, over the course of the next roughly 2.5 weeks that we have remaining before the exam, it may seem very disjointed because I'm going to pick things that are more likely to be on the exam and chuck things that are less likely to be on the exam in an effort to give you more high-value topics.
So how much do we have?
Don't ask.
It's a lot.
It is. The stuff that's at the end, I save for the end because it's fresher when you take the exam. Now, when you look at this chart, all right, gases we've already done. So that should be the easiest piece of this to fill in simply because it's on your test tomorrow. So what can you tell me about the motion of a gas? All right, they have the fastest motion. Why would they have the fastest motion? They're what? They're most spread apart. All right, so if they're the most spread apart, do they have any type of arrangement? No. There is no arrangement at all. Now, what kind of attractive forces do they have? They do. They want to get away from one another, so they have the absolute weakest. All right. Now, when we talk about attractive forces, these are your LDF, your dipole-dipole, and your hydrogen bonding. Now, if you're far apart, you can't attract one another. So the gases are going to be the weakest of the attractive forces because they're the farthest apart and they're moving the fastest. Now, huh?
The LDF.
Yes.
Only gas.
Only gas. Well, no, they all apply to liquids and solids also. Okay. Now, for liquids, what happens to their motion? Okay, so will they be faster or slower?
Slower.
Okay, they'll be slower than a gas. Okay, what can you tell me about the arrangement? Okay. Can they move past one another or are they in fixed positions? Okay, they can slide past each other. All right, and what can you tell me about their attractive forces? Okay. All right, they're stronger than a gas because they're much closer together. All right, so how would a solid compare to that?
So LDF and dipole and all that goes slowly, right?
The LDF, the dipole, and the hydrogen bond go with all three of them. So the liquid hydrogen bonding or dipole, whichever one it has, will be much stronger for a liquid than it would be for a gas because the particles are just closer together. So whichever one it had, it would be a much greater attraction. All right, so how would a solid compare? Okay, it would be the slowest. Now, when we think about the motion, all right, think about what we talked about. What were the three types of motion we said that they could have to begin with for the test for tomorrow? Vibrational, rotational, starts with a T. Translational. What's the only kind of solid can have? A vibration. Okay, so solids vibrate in place. Okay, so your gas and your liquid can translate and rotate, but can a solid do those things? Huh? They're the ones that are in fixed positions. Okay, so solids vibrate in place, or let me say this, fixed positions. Okay? Say what now? Shakes. Yep. Devon did a nice job with his pencil. Well, do it again, Devontae. All right. So the arrangement, I should probably move over here. All right. They're in fixed positions. All right. When we talked about ionic solids, this is where our crystal lattice came from. Okay. That's where our crystal lattice came from. No. The only one that's on this test is which column up here, or which row, I should say. The gas is on this test. Okay. Solids and liquids are not. Okay. You won't see this until you see it on a quiz. Quizzes are not over. The only thing that's over after tomorrow is a what? A test.
So this is new information. This is not on the test.
This is new information. It's not on the test. The only thing that's on the test tomorrow is the row that says gas. And on the next couple slides where we talk about properties, the ones that apply to gases are still on the test tomorrow because the test tomorrow is about what? Gases. So the ones that apply to liquids and solids are not on the test. No. Right. That's not on the test tomorrow. Okay. I'm just tying it into old stuff because you have an exam coming up. Yes, dear.
The gas, like that, and what are we supposed to do? Is it like common sense?
I would think so myself, but you know, y'all tell me. I know that's why I was going with that.
Think about me.
I think a lot of it. I think a lot of it for students with the gases is common sense. Yes, I mean particularly those of you who had a decent science background. Now, if you haven't had a decent science background, maybe not. I mean, do gases fill to expand to their container?
Wait, what? Repeat that.
Do gases expand to fill their containers? Okay. Do liquids expand to fill their containers? Okay, this is where we lose ourselves with common sense then. All right, back when I was a prolific Pepsi drinker, okay, I've given that up. I almost took a swig of Coke yesterday, and I didn't, but I almost did. Oh, it was a huge trial. Oh, it was hard. You just don't know how big a trial that was. I picked up the water instead. It was. I'm telling you. That is my drug of choice. But I did pick up the water. My point is, when I drank, I mean, I almost straight lined that stuff. Angel can tell you, I'd never not had a Pepsi in my hand during fourth period last year. Now, my point is, when I drank half the bottle down, did it regenerate itself? No. Gases will automatically expand to fill the container. It cannot stop itself from expanding and filling the container. But a liquid will not automatically expand and fill the entire container. Okay? Liquids don't do that. Do solids do that? No. So gases are the only thing that will expand. Okay? Gases can be compressed so that you can put them in a smaller space. Can liquids and solids be compressed? No. I mean, think about it. Can you squish water? What happens when you squish water? It goes everywhere.
I don't know, I've never tried.
Well, don't do it in here. Try it in the shower, okay? Or a bathtub or outside, because it makes a mess, okay? It's not going to work, all right? The reason is, when you look at these pictures, all right, there's a lot of space between the gas molecules. So you could get the molecules to get closer together because there's nothing in between them but space. But when you look at the liquid molecules, is there a lot of space between those molecules? No, there's not a lot of space. And because there's not a lot of space, you can't really compress them. For a solid, is there any space? No. So you cannot compress a solid at all. So people will bring up examples like cork. Can you compress cork? They're like, yeah. What is in cork that allows it to be compressed? Air. They're air pockets. You're just compressing the gas out of the cork. You're not really compressing the solid. Okay? A solid is incompressible. Say what now? Are you?
I was going to say, like, what are we talking about? You just wait for it. I mean, I know what it is now.
Okay.
Not that slow.
Oh, I was going to get an example for you. Okay.
I thought you said fork for a minute.
No.
No.
All right, so to finish our chart, what could you tell me about the attractive forces for a solid? They'd be the strongest. Why would these be the strongest? That's right. All right, they're the strongest because the particles are the closest together. Yes, ma'am. Sure. I don't want you to be parched. All right, everybody got it?
So, like, are we talking like you have a balloon, there's air in the balloon, right?
Yes.
Well, like in water, you can do that too, but it will bottom.
Yes. I mean, well, the biggest thing is if you try to push the water to compress it in a balloon, what's it going to do? It would pop, or if it was able to, it would like squish out of your hand so that it would change shape, or when you like pushed it like here, it would squish out here or out that way, but it's going to move. If it didn't have anywhere to go, it would pop. Okay? All right. Let me see. Where are my properties I want? There they are.
What to change?
All right. Tell me what fluidity is. Okay. Okay, the ability to flow. The particles will move. All right, so thinking about our states of matter, who has the ability to flow or is fluid? All right, Chris says gas and liquid. What do the rest of y'all think?
I know liquid for sure.
Definitely liquid brown.
Okay, definitely liquid. All right, and I got some hesitation on agreeing with him with gas. Why do y'all hesitate to agree with him on gas? Okay, so why?
Gas.
Like an air vent, that works too, though.
Okay, so in order to flow, the particles have to be able to do what? To move. So can the particles move in that picture?
Yeah.
Yes. So a gas is a fluid. All right. So tomorrow on the test, should you pick that a gas is a fluid if I ask you a question about that in the multiple choice?
Yes.
Yes, a gas is a fluid. Okay. Now, let's see.
What are we doing? What is this?
Properties.
No, what are they playing?
I have no idea.
I feel like I'm in a circus and it's very aggravating.
Sounds like a freaking electricity.
It sounds like a
Right. Why they change this mic?
Is that better?
Did you yell at them to turn it down? No, close the door.
Let's close the door.
I mean, hey.
All right. Compressible. All right.
To be compressed.
Okay.
I don't know how it works.
So basically only, I mean,
Here, we use a very technical term.
Now, squish. Squish is not technical.
I know.
All
All right. So who can we compress?
Yes.
Yeah, gases are compressible. All right.
Is that it?
That's it.
Okay.
Now, I will say this. All right. Because everybody wants to argue with me about liquids. All right. We say liquids are relatively incompressible. Okay, that's how we describe liquids. We use the word relatively, meaning, yes, there's a tiny bit of space between the liquid particles, but in the grand scheme of things, with that itty bitty amount of space, can we really compress a liquid? No. So on the test, for the purposes of compressible, can we really compress a liquid? No. We can compress a gas. We cannot compress a liquid. Okay? There's just not enough space.
Is plasma?
Plasma's in its own category. It has its own state of matter. We just don't talk about them in here.
Liquid, or is it plasma?
Plasma's its own state of matter.
Isn't that like lightning?
A plasma or lightning is actually the transfer of electrons from one area to another. It's not a state.
Like, what's an example of that?
The sun, stars, the sun.
Oh. What is yogurt? So nothing we can really relate to.
No.
Wait, I need a positive.
All right. How about
Oh, you heard them as well.
what?
You said that you have plasma in your blood. Oh, that's true though.
Well, I got a
Platelets,
question for
right?
you.
Not like
What?
plasma
What?
in your blood.
I have no idea. I am not a biology teacher. That's one of those people. The last time I had biology was 1989. I don't know the parts of the cell.
What is yogurt?
Yogurt is gross.
What? No, what is it? Like what? It's a solid? Like milk?
Did you say milk?
I call it a solid.
I mean,
but like, it's kind of like.
What?
Oh, you're talking about the solid.
What?
No, yogurt.
Oh, I thought that was
Whatever. Moving on.
water.
It ain't on the state test. Evaporation.
Solid.
All right. What's evaporation?
A little bit of evaporation. Turn into a vapor. It turns to gas. Yeah.
Okay. So a liquid to a
Yeah.
gas. Okay. So give me something else you might see for a property. How about freezing? We're going to talk about this too. This is all on Wednesday's agenda. That would be what? All right. has definite shape. Have a definite volume. All right. So we think both? We think one.
Well, you can't have any more liquid than you already have.
Okay, so we think both?
Yeah.
Okay. It is.
Wait, so do solids, like what solid, liquid, or gases go evaporating and freezing?
Evaporation would fit with what? What do you start as?
Liquid.
Yep. And freezing, you start as a what?
Liquid.
Yep. Let's see. Surface tension. That's a new one. I'll hold that one for a minute. If you remind me Wednesday, I'll drag out the overhead to show you that because that goes well with something that we need to do in January. Expansion. We're going to talk about expansion. What's expansion?
Yes.
Yeah, I know. What is it first?
Like particles going out.
Okay.
Expand.
This is hard. Oh, yeah, I think to say that is me.
Okay. I can live with the particles spread out. That's fine. All right. Who does it? I hear gas. Is that it?
No,
Just
Yeah.
Sometimes
Just
whenever they
right, because I mean,
I don't know, I mean, if you put like.
What do you say?
If
We
you
just
do a
know,
bowl,
we
it
just
didn't
know.
stay in the spot. Like, go out. If you transfer it from a container to another container.
Did we not just go over this?
this?
Or
So
is
they're
it
not
not
saying
the same thing?
We did just go over this. It's just a gas. I'm just looking at y'all, and now I'm just like, didn't we just talk about this? It's just a gas.
Wait, where did we run off?
You just remember the Pepsi story? It just doesn't regenerate itself. If it did, people wouldn't be going to ask to refill their water bottles all the time. All right.
All the time.
Diffusion. All right, what's diffusion?
It's a gas. It's like when it spreads out
Is
throughout.
that wrong?
No, that's not. Okay. All right. The definition that I gave you is a spontaneous
What?
mixing. Okay. Now, there's nothing wrong with Jada's definition. When she talked about, she said high pressure to low pressure, which is fine. It's actually an area of high concentration and low concentration.
Question.
Uh-huh.
So, when we talked about it, you said something about like perfume, right?
Yeah. So,
Right.
Mhm.
What are you mixing?
your
The air.
perfume with the rest of the air. Oh.
Stupid.
So the perfume is high concentration with the rest of the air is low concentration. If someone passes gas, their smell, gas is high concentration too. Low concentration is the rest of the room / the rest of the air. All right. Spontaneous meaning you can't stop it. When you spray whatever scent it is you've sprayed, it's not going to stay in your tight little area over there with you, and only you get to smell the scent that you clearly like. The rest of us will be subjected to it also. Okay? Huh? Yes. Gas, certainly. Anybody else?
I mean,
We
if
don't
you
know.
stay on the liquid, it's only smell it, so tea or soup. Yeah, like where you make
All of them.
What? Right, because perfume is okay.
All of them. All right? If you put food coloring in water, will the food coloring cause the rest of the water to change?
That's an example of a liquid.
That's an example of a liquid. All right? The solid is much harder to do. But if you took two metals and clamped them together so they were clamped together for 20 years, you would find that the two metals would actually diffuse together. No, we do not have time for that experiment.
Why not?
I'll be long retired. All right. However, it would actually happen over time. Now, so I think most of us would be okay with saying which one would be the fastest. Gas would be the fastest. And this would certainly be the slowest. All right. The solid is going to be the slowest and the gas is going to be the fastest. All right. And the gas is going to be the fastest because the particles are what? They are moving faster, but they're also what? They're farther apart. Okay. It's a lot like right now if I send you up the hallway. Right now, is there a lot of people in the hallway? No. But if I wait, you can move faster. But if I wait to the change of class, is it easy to get up and down the hallways? No. Huh? It's true, but still, you got to take the time to push them so it slows you down. But if I let you just run up the hallway right now, there's nobody in your way, so you can go faster. Okay? Can we do that experiment? I don't think Miss Curry would approve, so let's not. All right? As much fun as that might be, I really just don't want to get in trouble today. All right, density. We need to do density and surface tension, and I think we're good. All right, what's density? How dense something is. I'm fairly certain we.
Particles are together.
Okay.
You basically held density.
Not wrong.
How close the particles are in a. I need a little more. In a what? We could put container in a spaceport. Okay? Because we know this is mass over a volume, which is why I was okay with how close they are in space. Now, all three of them have a density, correct? Yeah. So again, we have a gas, we have a liquid, and we have a solid. All of them have a density. So whose would be the highest?
Solid.
Whose would be the lowest? Now, density we talked about for this test. Okay, diffusion. We talked about the diffusion of a gas for this test. We didn't talk about liquids and solids for the test. We did talk about a gas and we did talk about density. So that you should know for the test. Surface tension, and then we're done. With the properties. Huh? I haven't decided.
I thought we should just.
She can practice with this.
We may.
Can you not hear anything?
All right, so the last property is surface tension.
This is gonna be a lot because I got like all these things.
A definition, and then we're going to talk about what things are good surface tension, what things are poor surface tension. All right, so you probably taught, I'm going to say capillary action in biology class. I don't know if you would have talked about surface tension. Oh, we didn't talk about the two types of solids. We got to do that today too. I forgot about that. All right, so sorry. I just turned to my notes to just make sure I didn't forget something. Clearly I did. All right, so what is surface tension? Anybody know? It's a force that tends to hold adjacent particles together in a liquid.
You have to think of solid and stuff like this.
Nope. It's a force that tends to hold adjacent particles together in a liquid. So, if you remind me, On Wednesday, I'll drag out the overhead projector and the wax paper. It really worked better when I had a different smart board than this one, but I can still make it work. All right. And when I do it, I'll get out some wax paper and I'll put water. I have water here. And I have alcohol here. Okay. Now, which one of those has good surface tension? Okay. So, why does water have good surface tension and the alcohol have poor surface tension? And when I do this, you'll see that the alcohol spreads out and gets really flat. It just sort of oozes and is flat all over the wax paper. And the alcohol, or the water rather, stays nice and tight and beaded up in a bubble. Okay? And you can do this at home and see. You don't have to do it with me. But the water stays in a tight beaded bubble and the alcohol gets really, really flat. So why does the water have good surface tension and the alcohol have really poor surface tension?
Or it's got stronger bonds or something?
It does? All right. What kind of bonds does it have? Okay. Now, where do those hydrogen bonds come from? Need the definition.
What?
Where the
How do you
bonds
get a
come from?
definition?
I mean,
It's based on the definition. Why does water have stronger? Caroline just said it had stronger hydrogen bonds.
I don't know.
They
They
have
have
higher
hydrogen
attractive
molecules
forces
bonded
between hydrogen and lone pairs of electrons.
Okay, now look up at dipole-dipole. It also has dipole-dipole attractive forces.
Attractive force between polar bonds.
Okay,
I thought they could only have one.
no, they can have two.
You-
All right.
Oh. That is extreme here. This is not right.
All right, so if they're polar molecules, they're going to be stronger. So what would you guess about alcohol then?
They have
They are. Alcohol is going to be weaker. Give me a reason why it's going to be weaker.
They yes.
Is what?
They have the-
What do you suppose?
They're non-polar.
Yes. Non-polar molecules have poor surface tension. Okay? So, what I want you to get out of this is polar molecules have good surface tension. Non-polar molecules have poor surface tension. Okay? Polar molecules have good surface tension. Non-polar molecules have poor surface tension. So water would be what kind of molecule then? If it had good surface tension, you should know water is what kind of molecule?
Polar.
Polar. Alcohol, since it's real flat, would be what kind of molecule? Non-polar. Questions? Need a tissue? Yeah. Okay. All right. Does everybody have it? All right. Last thing. I just remembered it when I flipped to my notes.
I don't have any more space.
Get another piece of paper
I don't,
or turn the page.
That's a lot of work.
All right. Two types of solids.
And they're two trains.
Never.
Sorry. All right, so there are two types of solids. I wish the snow had been this week and not last week. We were going to get it.
Yeah, me too, because then it would have just gone right into the snow.
I know. That'd been so cool.
Yeah, my birthday, not so long.
But it was not to be. All right, so
I honestly think it was. I was surprised.
I thought it was going to snow, but I didn't think we'd be out a full week. All right, crystalline and amorphous are the two types of solids that we've talked about this year. All right, now crystalline is the one we've spent the most time with. All right, what does it mean to be crystalline? It means you have a definite crystalline pattern, which means you have a definite melting point. Now, when I say you have a definite crystalline pattern, you remember the, I don't remember when I said this, would have been back during bonding, when we did the crystal lattices. I told you there were 7 unit cell patterns, okay? You have to be one of the 7 unit cell patterns. Now, you do not need to know what the 7 unit cell patterns are, but you have to have one of those 7 patterns. Now, I will even use this word. They are a geometric pattern, all right? Now, there are 2 of them I'm going to tell you have to know. They're salt, sugar, and water. There are 3 of them, actually. Can't count. All right? And they have a definite melting point, meaning when you reach that temperature, they automatically melt. Now, an amorphous solid has a random arrangement of particles and it melts over a range of temperatures. Okay? Has a random arrangement of particles and it melts over a range of temperatures. So, how are we going to tell the difference between the 2? All right. To give you a general idea, salt, sugar, and ice all fit in this category. All right. Anything that's a crystal would fit here. If you ever grew, any of y'all ever grow crystals in elementary or middle school? I got a couple of nods. With the strings, maybe a paper clip or a toothpick or something, and you made a solution and you tried to grow crystals on it, that's going to fit in crystalline. Okay? Huh? Yes, melts over a range. Okay? If you ever buy the little candy on a stick that looks like it's got crystals, rock candy, that's crystalline. Any of you who wear jewelry that's emeralds, diamonds, sapphires, rubies, that's crystalline. Okay? Now, salt has a cubic pattern. Sugar is a cubic pattern. Ice is hexagonal. You have to know those 3, just because I'm hard to get along with. Now, we talked about density a minute ago, right? Which density did we say was the biggest or the heaviest? Out of solids, liquids, and gases, who is the heaviest? Solids. So generally speaking, what happens to solids? Do they float or sink? They sink. But ice is an exception, right? Why? Well, when ice forms in a hexagonal pattern. Okay? Its crystals form in this shape. Well, when it freezes in this shape, air is trapped in each one of these hexagons. So if air gets trapped in each of these hexagons, the density of ice becomes less than the liquid, which is why ice floats. Okay? That's why it floats. Now, amorphous. What things are going to fit in amorphous that melts over a range of temperatures? Any ideas? The things don't melt at one specific temperature. Melts over a range. Yeah, he did. Who's ever melted yogurt?
Yeah,
You're
that's
weird.
Is that a thing?
Lolly has it stuck in his head.
What do you think?
It's about yogurt.
What things would melt over a range?
Butter.
Yes.
Wow.
Plastic? Oh, it stinks when it melts. I have
Rubber.
never melted. Like if you accidentally like get a like glass scratch. Someone, I said butter.
Oh, stuff like
Okay.
that.
Explain.
Oh, like it's silicone?
No.
It's not. They're gonna have it in. It is? Yay.
All right, glass is made of largely silicone. All right, silicone is the major ingredient in sand. Sand is glass. All right, plastic, rubber, wax, glass, tar, fiber optics.
What is
Okay, those things are going to be amorphous. They melt over a range of temperatures, not at one specific temperature. Okay, questions? Fiber optics. Have you ever seen like Christmas ornaments that change colors constantly?
Ornaments or lights?
You mean like
Lights.
actually change lights?
They're the glass pieces in the ornaments. You see them in trees. Yeah, they're also used in like phone lines, cables for various things.
Even better off than
It is made of glass. If you get shards of that stuff in your hands, it hurts like a lot. Let's just go with a lot. Okay? You would not want to get that in your hands. It would
Are
hurt.
we talking about Christmas lights or Christmas ornaments?
Depends
Depends.
on what it's in. I mean, we have a tree at our house that has fiber optics in it. I've seen it in ornaments. I've seen it in trees. I've seen it. My sister has a snowman that has fiber optics in it
Oh, that's like.
that changes colors when it's plugged in. Yeah.
Those weird little things you get like from there. Little toys.
Probably.
My sister always wants those little wand things that change like.
Yes, those would probably have fiber optics in them also. Yes. Okay. But you don't want to break the fiber optics because they're made of glass.
But you don't want to break glass.
Exactly. The little shards would seriously hurt. Okay. Questions?
A lot.
Yeah, just go with a lot. You did what? Oh.
I was at work and one of those candles, like,
Oh, you should have sued them.
someone was trying to, somebody asked me to put the lid back on it, and apparently my conscience just went to the dark and glass blew in my ear. It didn't hurt, it itched really bad.
It's gonna hurt one day when it reaches your brain.
Okay.
I got it out.
All
I
right.
can get it out.
He's got it out.
Now, tomorrow, we're taking the test on the gas laws. I've got everything I wanted done today done. So, I've given you at this point a multiple choice worksheet that I will post the answers for at some point today. Third period, I've got to go, or second period, I've got to go to the hand therapy today. So,
What is that like? What do they make you do?
they're going to yell at me
Like
today because
this?
I haven't done my exercises.
Oh, I never do exercises.
They won't be.
What do you do? Like pick up things? Right. Yeah, like squeeze.
No, I think that's exercise my fingers because I still can't make a fit 5 minute exercise.
Why don't you
I gotta do
just?
some therapy stuff to actually work on my strength because I keep dropping everything I do that either. I only have 2 appointments left this week and next week. I'm done.
This is me. Like,
Do they
I
give
know
you
what I can do.
I got a t-shirt when I finished mine.
I don't think I get it.
Sticker you asked them.
It's gonna set me on my merry way with less than 4
They said I graduated, they're gonna give me free t-shirts.
We could do this.
Yeah, I can do that one. Okay, good there. And everybody freaked out last week. I didn't know. Now, if you need help this afternoon, I will be here. You need tutoring. Put your calculators up. All right, let me mark that here. That here.
Okay, I don't want to. I'll get it.
Yes, you do.
I got it.
Oh, I know.
I would never do that.
Wait, so do we have the talent show like for sure Friday?
It's Friday.
I think so.
I would-
No.
And if you're not gonna be here Friday, they said there's no refunds if you bought your tickets, so, you might just wanna show up and.
That's what I got here.
I don't like
But I want this.
Put your butt to the chair.
Winnie is the. I had it with EOS on the blue mold on the outside of it, not on the actual lip balm, but on the How you gonna take my cup? My boyfriend. And his grandma.
The main